Hi everyone, so we're going to be looking at simplifying expressions today. So an expression is not something to be solved. It tends to be a case of you've got a bunch of different terms put together, whether or not it's multiply, add or subtract, and we're just trying to make it a little bit more simple. All right, so I'm going to go through a bunch of examples for you to look at, and if you're asked to leave something in a simplified version, then of course this is some of the techniques that you're going to need, and you're going to come across this in many parts of algebra, many parts of kind of questions as you progress through obviously your learning. All right, so let's have a look. So if terms have the same letter, they can be added or subtracted. All right, so for example, so 4x plus 3x is going to give you 7x. All right, so it's literally how many x's? I've got 4 of them and another 3 of them is going to give me 7. All right, similarly with subtraction, if I've got 6 of something and I take away 2 of something, so 6x take away 2x is just going to give me 4x. All right, 7a plus 4a plus a. All right, in terms of the number of a's, or again, the same kind of process is that how many a's I've got? Well, I've got 7, I've got 4, that's going to be 11. And you'll notice that the number that is missing from this one is just 1. All right, we tend not to write 1a for some reason or other. It's just because when we're talking about one variable, we just have a variable effectively, so we drop the number with it. All right, but it is one of them. So I've got 7 and 4, which is 11, plus another one, it's going to give me 12. So that's going to be 12a. Okay. This is a little bit different, and again, I've kind of thrown it in there just to make sure that you're aware that, well, whilst we're adding things with letters, if it doesn't have a letter, then we can't bring them together. Okay, we have to leave them separate. So in this case, I've got 4g and 9g. All right, so they're okay. So that's going to give me 13g. But because the 6 is just a number, then I have to leave it as it is. All right, so the only way when we're simplifying expressions, it must have the same letter and not a number on its own. Otherwise, we have to kind of leave them separate. Okay, so let's have a look at some other ones. So what was if they've got different letters? All right, well, we can only really add them or bring them together if they're both the same, and they have to be exactly the same. All right, so and again, from this you can see I've already written in there. Please look carefully at the sign in front, because if you've got a long string of them, it's going to make it a little bit more awkward to kind of deal with. All right, so let's have a look. So here we go. So you can see there's quite a few going on here. So what we'll look at first of all, you can see there's x and y's in the expression. So we're going to bring our x's together. So I've got 3x plus 7x. So again, what's in front? So that's going to give me 10x's. And I've got 2y's plus 2y's plus 4y. And so that's going to give me plus 6y. So I'll have 10x plus 6y. All right. Right, so here, this is where we need to be a bit careful. And we see a negative that's involved. So let's do a's first. So 5a take away a. All right, so 5a take away, that's going to give me 4a. And now I've got plus 6b plus 3b, and that's going to give me plus 9b. All right, so hopefully you can see what I'm doing there. I'm keeping a very, very close eye on the sign that's in front. Okay, all right, here we go. So it's getting a bit more awkward now. So again, focusing on the r's, I've got 5r, take away 3r, so that's going to give me 2r, the first bit. And then I've got 6s, take away 10s, which is going to give me negative 4 minus 4s. Okay, so there you go. All right, so when we're simplifying expressions, all right, we are looking to kind of bring together the groups with letters, but we have to be kind of careful that it is exactly the same in both cases. All right. Right, multiplying expressions. So when we're multiplying expressions, you multiply the numbers that we can, and of course we will then try and multiply the power in the same way. All right, so we take numbers and letters all separately. All right, so let's have a look in terms of example. So here we've got 3a times 4b. Well, the numbers we can multiply. So what's 3 times 4? And that's going to give us 12. But the two letters are different. And because the two letters are different, we can't times them together as such. So because when we're timesing letters together, then we just literally put them next to each other. All right, so it's a times b effectively. All right, so it's 12 times a times b. All right, that's what you actually got. But we write it as 12ab. All right. Well, what about this one, where you've got 6c times c? Well, there's no other numbers, so it's definitely 6. But how do we write 6 times 6? Well, it says in the top here, if we're multiplying the same letter together, then we need to use powers. All right, so it's a case of how many c's have we got? Well, there's 2 of them. So that means it's going to be to the power 2. All right, so it's 6c squared. All right, so that's how we do it when we're talking about with letters. Right, let's have a look at this one. So quite a bit going on. So we're going to take the numbers first, and then we're going to consider each of the letters separately. Right, so what's 5 times 9? That's going to be 45. We've got d times d. That'll give us a d squared. There's only one e and there's only one f. So what's going to happen is 45 times d squared times e times f. So 45 d squared ef. 45 d squared ef. There you go. All right, hopefully you followed that. Right, what about this last one then? So 8y squared times 3y squared. So 8 times 3, let's do the numbers first, is going to be 24. And then we're looking at y squared times y. Well, I've got 2 y's here and another y there, so it's going to be y cubed. So it's 24 y cubed. All right, and there you go. All right, so that's all you need to do when multiplying. So finally, we are going to look at division because it makes sense to just do all the operations. So when dividing expressions, you divide the numbers like we did with the multiplying. And when we're dividing the letters, we do so with the letters, all right? But of course, that makes no sense without some examples. So let's look at some examples to kind of help us along. Okay, so let's have a look at these ones. So we've got 12p divided by 3p, okay? Well, 12 divided by 3 is 4, all right? 12 divided by 3 is 4. But we've got a p and a p. Well, these are both the same, all right? Now, I'm going to say this, and you'll hear this kind of mentioned in other lessons by other teachers, is that if you've got something which is top and bottom, like this, then they're going to cancel each other out. And what that means is, if I think about p divided by p, or any number divided by the same number, it becomes 1, okay? So p divided by p is 1, therefore it kind of disappears, because if I did 4 times 1, it would still be 4. So the terminology you'll hear people saying is it cancels each other out, all right? But essentially, when I do p divided by p, it's 1, and when I times anything by 1, it's exactly the same thing. So it tends to disappear, all right? So in this case, I do 12 divided by 3, which is 4, and then the p's cancel each other out, so you're just left with 4, all right? What about this one, all right? So what we've got, well, we've got 15 divided by 5, so that's going to give us a 3. And then what we've got here, we've got 6 A's and 2 A's, all right? Well, you can apply this to rules of indices if you wish. So if you've not looked at the lesson on indices, then you might wish to. When I do A6 divided by A2, what happens is there are 6 A's here and there are 2 A's here, all right? That means 2 of them are going to cancel out because there's 2 top and bottom, and it's going to leave me with 4 left, all right? So I'm going to have 3 A to the power 4. All right, 3a to the power 4, all right? But the idea of a to the 6 divided by a squared is that you've got 6's at the top, 6 a's at the top, you've got 2 a's at the bottom, and so that means the 2 of the a's, top and bottom, will cancel each other out, and you're left with the 4. All right, so, okay, so big one. So 24c to the 7 d cubed over 4c d to the 5. Right, so we're going to treat these all very, very separately. So we'll do 24 divided by 4, which gives me 6. We've got 7 c's at the top and 1 at the bottom. So that means 1 will cancel out, so I'm going to have c to the 6. The 3 d's at the top will cancel with 3 d's at the bottom, leaving 2 d's at the bottom. So I have d squared at the bottom. So what I'm expecting is 6 c to the 6 over d squared. All right, so there you go. 6 c to the 6 over d squared. Now your question may be is why is it written like this? Why is it written as d to the minus 2? All right. Well, if you haven't looked at the lesson on indices, then you won't understand what that's all about. But ultimately, if you do anything to a negative power, it means 1 over that. All right. So actually, this is 6c to the 6 divided by d squared. All right. That's exactly what that is. All right. It's just a different way of writing it. All right, so don't worry too much about it. What I said originally was absolutely right. 6c to the 6 divided by d squared, okay? But also can be written d to the minus 2. All right, so all these kind of concepts that I've kind of gone through is an awful lot to kind of take in. Obviously, the video is there and the lessons are there available to have a look at. So visit maths-school.co.uk. The link is at the bottom of this anyway, to do some additional practice. And of course, please revisit the video at any time you like. Well, thanks for listening.